What is Hawking radiation? My name is Daniel Groskopf, and I will be discussing with you the idea of Hawking radiation. But first, we need to understand two core concepts. The first is particles and antiparticles. The second is black holes. Now, you already know what particles are. They're everywhere. There's stuff, mass, what you think of as things. Okay, but there's this other side of antiparticles. Now, let's go back to Einstein. Now, Einstein had this idea that energy is equal to mass times the speed of light squared. And what's interesting about that for us right now is that energy is equated to mass. So an increase in mass means an increase in energy. A decrease in mass means a decrease in energy. That's how you get the atomic bomb effect. If you reduce the mass in an atom, all this energy has to escape in order to keep that equation equal. So let's go to outer space and we think of space as being nothing, or let's think about it as zero, okay? And if we get an influx of energy into this zero equation, it can actually knock this space apart, and you end up with a particle and an antiparticle. Now, the antiparticle is -1 and the particle is 1, so it still equals. And what can happen is if these two end up coming back together, they can actually annihilate each other, and then you end up back at 0. Now, the other concept that I think that we need to talk about are black holes. Now, you probably know what a black hole is. It's something that's so dense, its gravity is so strong that nothing can escape it. It gets inside the area around the black hole and it will just suck it in, including light. That's why it's black. You can't see it because it sucks all the light into it. And nothing can escape. Or so we thought, until this guy named Stephen Hawking came along and started observing black holes and running incredibly complex mathematical calculations and started to realize something is escaping from black holes. What is this thing that's escaping from black holes? This radiation, which we now know as Hawking radiation. So let's go back, all right? So we have this space that ends up getting broken apart, and you've got your particle and your antiparticle. And what can happen is the antiparticle can get sucked into the black hole, and this particle can escape. Now, this antiparticle, will annihilate mass inside the black hole, effectively causing the black hole to slowly evaporate. Well, this particle is emitted as what we now know as Hawking radiation.